Okay, class, today we're in lesson 7.2, equations with rational numbers. Lesson 7.2, equations with rational numbers.
You know, not all multi-step equations look the same. Let's take a look at some and see how we could use different techniques to solve different types of equations. Check it out. 2y over 5 plus 3/5 equals negative 1/5. How in the world are we going to solve that? Well, I'm going to show you right now. Because what you want to do is notice that what is it that you don't like about this particular equation? It's all those fractions. Oh no, fractions. They make life a little bit difficult sometimes. So it would be great if we could just get rid of the fractions. Now we can. If we could figure out the least common denominator, which in this case is easy, it's all 5, so we know the least common denominator, the LCD, is 5, then we can multiply both sides of the equation through carefully by 5, and that should clear out all the denominators. Let's see that in action. So first I'm just going to write down the equation as is. So I'm just copying this down. Nothing special. But now I'm going to multiply both sides by the least common denominator of 5, 5, and 5, which is just 5. So this side I multiply by 5, and this side I multiply by 5. Notice I'm putting parentheses around everything, because in this case I have to make sure that 5 multiplies not only this term, but also multiplies this term. Namely, I've got to distribute that 5 across to here, and also way over to here. So you have to remember that. So putting parentheses helps me remember that. Anyway, let's now multiply through. When I multiply through by 5, I see that I can simplify the 5 in the numerator and the 5 in the denominator, and I'm just left with 2y plus, and then again here I see 5 factor in the numerator, a 5 factor in the denominator, so in fact they simplify, and I'm just left with that 3. And here the 5 in the denominator and the 5 in the numerator, well in fact they can be simplified, but don't forget that negative sign, so I'm left with a negative 1. Alright, great. Well now I just will get the y's on their own by first getting rid of this adding of 3 by subtracting 3 from both sides. Remember, if I do something to one side, I've got to do it to the other, otherwise it won't be a well-balanced equation. And you want to start your day off with a well-balanced equation. Negative 1 minus 3 is negative 4. And now, to undo the multiplication by 2, I'm going to divide both sides by 2. This is looking good. And I've got y equals, and I've got negative 4 divided by 2. Well, a negative divided by a positive is a negative. 4 divided by 2 is 2, so we have y equals negative 2. And that's the answer. You can check if you want, but I won't. I'm so excited that we got y equals negative 2 to be the answer, even with fractions. Let's try one more together and see that, in fact, the fractions should not scare us. Multi-step. Can't get more steppy than this. X divided by 3 minus x divided by 4 plus 5/6 equals 1/2. Wow. Well, lots of denominators, so first let's find the least common denominator for 3, 4, 6, and 2. And if we compute that, we see the answer is 12. Namely, 12 is the smallest number that has 3 as a factor, 4 as a factor, 6 as a factor, and 2 as a factor. So let's multiply both sides through by 12. Now if we do that, we have to remember that we have to multiply every single term on the left by 12, and then, of course, this term on the right by 12. And so when we do that, what do we see? Well, if we simplify 12, and then I'm dividing by 3, that's going to give me a 4. So I have 4x in the first term, minus, and when I multiply this by 12, 12 divided by 4 is 3, so I have a 3x. When I multiply this by 12, 12 divided by 6 is 2, 2 times 5 is 10, so I have a 10, and that equals 12 times 1/2 is the same thing as 12 divided by 2, which is 6. So when I take this equation and multiply every term on each side by 12, it becomes this equation. Now, this equation we can actually simplify, because first of all, 4x minus 3x, if I have 4x's and someone takes 3x's away, how many x's do I have? I've got 1x. And then I've got plus 10 equals 6. And now, if I want to undo the adding of 10, I'll subtract. I'm going to use my math out. Whew. Isn't it good to have some math out around? It's always helpful. So subtract 10 from both sides because we want to undo the addition. And I see x equals 6 minus 10, which is negative 4. And so the answer to this really complicated multi-step equation turns out to be negative 4. Oh, hey, come on, join me. I'm just finishing up my run. It's good to sort of do some cardiovascular thing. I think math is, I'm going to really speed up now. Here you go, look at me. Woohoo, look at me run. Okay, slow down. Okay. All right, and now I'm going to start to walk it off. Okay, walking off. Wow, that was good. And you know, actually, this running thing reminds me of an interesting question that I was thinking about while I was on my run. Maybe you want to join me. Here's the question. So I run the same distance every day. Now, on Mondays and Fridays and Saturdays, I run 5 laps on the track, and then I run 3 more miles. On Tuesdays and Thursdays, I run 7 laps on the track and then run 1.5 miles. And on Wednesdays, I just run laps around the track. Question is, how many laps did I run on Wednesdays? Interesting. All right, let's stop. Whew. Okay, a little bit of water. Oh, it's empty. That's sort of sad. You know, you want water at the end of a run, and yet apparently the prop people don't want me to be hydrated. Okay, that's fine. All right. Let's wipe. Wiping myself with an old sock. Okay, this is not good. All right, anyway, back to work. So, we don't know the length of the lap. So we got to first of all find how far once around the track is. Now, the one thing we do know is that the distance I run every single day is the same. So let's call the length of once around the track L. Then how much did I run? How far did I run, let's say on Monday? Well, 5 laps, that would be 5 times L, and then plus an additional 3 miles. So I've got 5L plus 3. That's how far I ran on Monday, in fact, on Friday and Saturday. Now, on Tuesday, I ran 7 laps, 7 times around the track. That'd be 7 times L, and an additional 1.5. So 7L plus an additional 1.5. And what do I know? I know that I always run the same distance every day, so these are equal. Notice that gives me an equation where the variable is on 2 sides, and if I solve it for the variable, I'll know the distance once around the track. So it won't answer the question, but it'll be the step to get me there. So let's see, what do I do? How do I solve this? Well, I guess I'd isolate some variables, so I'm going to subtract the 5L from both sides. And when I do that, let's see what we get. Here I see 5L minus 5L is 0. I'm left with a 3 equals 7L minus 5L is 2L plus 1.5. If I now subtract 1.5 from both sides, 3 minus 1.5 is 1.5. That's going to equal 2L, and this is 0. Divide both sides by 2, and I see L equals 0.75. And the units here are miles, by the way. So once around the track is going to be 0.75 miles. Okay, so that's great. But where does that lead us? What do we do next? Well, I want to know how many times I went around the track on Wednesday. Now, Wednesday, I only run track. I don't do any additional stuff. So how many laps did I do if the length of one time around is 0.75? I still don't know. I have to return to the information that we're given at the beginning, which is that I run the same distance every day. So what I've got to do now is find out how far I run on any one day, which I can now do because I know the length of what's around, and I know this is how far I've gone, for example, on Monday. So if I let L equal 0.75 and compute that number, that will tell me how far I travel every single day on my run. So let's do that right now. So I run, so each day, I run. Well, I could plug in 0.75 into here or to here because I know they're going to be equal at that moment. So let me plug it into here, let's say. 5 times 0.75 plus 3. And that works out to be 6.75. So that's how many miles I run a day. You should be impressed. Thank you. All right. Now, if that's how many miles I run a day, and I know that on Wednesday I just keep running around the track and nothing else, then really I know that the number of times I run around the track, let's call it, say, X, is going to satisfy the following thing. Well, each time around is going to be 0.75 of a mile times the number I travel around the track has to equal the total number of miles I travel that day. And so now to solve this, I just divide both sides by 0.75. And I see in this case, X equals 9. So I travel around or run around the track on Wednesdays exactly 9 times, and that's going to allow me to run exactly 6.75 miles that day, which is the same amount of miles I run every single day. You know, running is great exercise. I'm actually still trying to actually cool down a little bit. In fact, you know what's sort of fun? You can actually cool down backwards. Watch this. Look at me going backwards. I need to pick up the pace a little bit. That's right. I'm running backwards. As long as you don't... Whoa, whoa, whoa.